All right. Now we're back to 1332. So we have to go back, instead of going to 0317, we're done with that. Now we're doing 1332. We're going to pick up where that one left off. We're going to do more algebra stuff. In this chapter, we're going to deal with linear equations. So the first one we're going to look at is section 1, are graphs and functions. Here are our objectives. We're going to plot points. We're going to graph equations. We're going to use function notation. We're going to graph functions. We're going to do a vertical line test. And you're going to find information about a function from the graph. So to begin with, what is a point? Yeah. The point is the location of a number, you can't use point. It's a location of an element in a coordinate system. Now, I left coordinate system pretty vague because you can have 2 dimensions. You can have 3 dimensions. And you can have four dimensions, because the 4th dimension will be time. So what we're going to look at, we're not going to look at 3 dimensions. That's in calculus. But we're going to look at 2-dimensional equations. So the type of system we're going to look at is called the Cartesian coordinate system. The reason it's called the Cartesian René Descartes. René Descartes was a French mathematician who one day was sick. He was lying down in bed and he looked up on the ceiling, similar to ours, has little tiles up there, and he noticed a spider crawling around up there. And he determined that at that point that he can tell you exactly the location of that spider by starting from a corner point, how many spaces to the left and spaces out that spider is. And that's where he came out with the Cartesian coordinate system. It belongs to René Descartes. We call it today, or some people do, the rectangular coordinate system. Other people know it as the XY graph. Okay, so a point is a location of an element, or whatever you're looking at, whether it's a point, whether it's a object in some sort of a coordinate system. We're going to be looking at a 2-dimension coordinate system, the X and Y coordinate system. In the beginning, when you first started learning math, you learned the number line. You had 0 in the middle and positive integers to the right, negative integers to the left, all the way to negative infinity. So when we're asked to, okay, plot the point 2. What would you do there? If I said, find the point x equals 2, you'd put a dot there because 2. So we call this horizontal version the x-axis. If you think about it, this is how humankind learned how to travel. Initially, we walked, rode horses, sailed boats, all horizontally. Put your phone away. And then, because things go up and down, we now developed another coordinate system. Going up was positive, all the way to positive infinity. Going down was negative, all the way down to negative infinity. So instead of being able to write x equals 2, we now have specific locations of these points. So the x-axis was the horizontal, and we called the vertical one the y-axis. Which is where the word coordinate came from. Co means together. The x-axis was known as the abscissa, and the y-axis was known as the ordinate. So coordinate with ordinate, so you had these two work together. So now a point is defined as an ordered pair. An ordered pair of what? An ordered pair of numbers. Where the first value in this ordered pair is the x value, and the y value is a second. This is universal, so no matter who's looking at your graph, they know exactly the location of these points. So what would be the location of this point here? The x is 2 and the y is 3. Now, how do you find these points? Well, you always start off from the middle point there. The middle point there is called the origin. That's where this entire graph system starts. Its location. What do you think the location of the origin is? 0, 0. Because it's not positive, it's not negative, going left and right. It's not positive, negative, going down, up and down. So it's 0, 0. So if I give you the point 2, 3, you start at the origin. That's where it says the origin. That's where it starts. Go to the right, since it's positive, go to the right 2, and then go up 3. That's how you find points. What would this one be? -3, 1. How about this one? Very good. -2, comma, -2. And that point, very good. 3, -2. So whenever you look at points, the first one, think alphabetically. X comes before Y, so the first one you go horizontally, then vertically. If it's positive, it goes right. If it's negative, it goes left. And the Y values, if it's positive, it goes up. If it's negative, it goes down. So the signs are simply directional indicators. Now, this coordinate system, we know that to the right is positive. To the left is negative. All the way to negative infinity. Up is positive. All the way to infinity. And down is negative. Since there are 4 squares, they're each called a quadrant. Quad means 4. So how would you label those? We'd label them quadrant 1, 2, 3, and 4. We use the Roman numerals to label the quadrants. Because that's the way it was done when it was first invented. So now where would we put, where's quadrant 1? Where would we label it? Where do you think quadrant 1 is? If you were inventing it, where would you put it?
Yeah.
Well, so where would you put first quadrant? Which way? Top left or top right, bottom left, bottom right? Why would you put it top right? No, you're trying to think of it. I'm thinking, if you were inventing this, how would you label these? You're trying to remember what you learned in high school. Normally, when we label things, we start in top left and work clockwise. No. You're right. It is top right. That's quadrant 1. Top left is quadrant 2. Bottom left is quadrant 3. And bottom right is quadrant 4. One theory of why this is labeled as such, because we would label things clockwise, wouldn't we? That's what we're used to. We're used to looking at clocks and they go to the right. They circle around to the right. But since we're going counterclockwise, this was invented because back then they used sundials. Sundial works on the sun. Where does the sun rise? In the east. Then it goes to the west. And then it keeps on going around. So that's the reason it's counterclockwise, because they didn't have clocks back then, they had sundials. Now, each one of these quadrants have unique characteristics. In the first quadrant, the x-axis is a positive or negative? It's positive. And if you go up, that's positive. So in the first quadrant, both numbers are positive. In the second quadrant, remember, start off from the origin. You have to go left, so that's negative. And then you go up, it's positive. Third quadrant, you go left, then down. Those are both negatives. And the fourth quadrant, you go right, then down. So by looking at the signs of the numbers, you can tell which quadrant the numbers are in. If they're both positive, you're in quadrant 1. Both negative, you're in quadrant 3. Negative, positive, you're in quadrant 2. What quadrant is negative 4, 3 in? 2, because you go left and then up. 5, negative 1. Yeah, because you go to the right, then you go down. So that's quadrant 4. Three, negative 2. Quadrant 2 again. Because you go left, then up. Remember, all these start off from the origin. So you go left, then up, you're in quadrant 2. Negative 5, negative 1. Yeah, because you go left, then down. And when they're both positive, you're in quadrant 1. What is a linear equation? What is a linear equation? An equation that defines a line. How do we know it's a line? Because the first 4 letters of linear is line. What does an equation look like? The forms of linear equations, we have 3 types, 3 forms. The first form is called the point slope form. Why is it called a point slope form? Because it has a point. Remember, a point is an x and y, so that's made up of the x1, y1 components. And it has a slope. slope is represented by the letter M. So the point is made up of these x1, y1. M is the slope. And then X and Y are the variables that define all the other points. That's the first one. Next one is Y equals MX plus B. Put your phone away. No, put it away, put it away. No, oh, no, not on your desk, away, put it away. Y'all remember this one? What's it called? That's called a slope-intercept form. Remember, the slope is registered by the letter M, and the y-intercept is denoted by the letter B. And the last one looks like this. AX plus BY equals C. Where A is always positive. If A is not positive, if A is negative, you have to change all their signs. A has to be positive. This is called the standard form. Right. The B is called the y-intercept. This one? No. Notice these are capital letters. A and B and C are simply numbers.
Oh, but it's a Y, right?
Yeah, it goes with the Y, yeah. It goes with the Y, yeah. A goes with the X, B goes with the Y, and C is a constant. Now, how do we graph equations? How do we graph equations? There are three ways of doing that. Three primary methods. The first one is by plotting points. For a linear equation, you only need 2 points to draw the graph. Once you have the 2 points, draw a line between them and you're done. The second method is called the intercept method. And we'll talk about that in the next section or two. Intercept method is where you find the X and Y intercepts plot them, and connect the dots. The third method is called the slope intercept method. Here, you plot the y-intercept, and then follow the slope to the next point. Those are the three methods. So let's look at an example of each of these. The first method, plotting points. Three x plus 2y equals 6. We're going to have plotting points. Remember, a point is an x and y ordered pair. For a line, you only need 2 points. So let's pick a value for x. Four. And let's pick a value for y. Three. This is the x, this is the y. Or you can pick 2 values for x. And then what's going to happen here is now we're going to have our ordered pair. These are our points. So for the first one, x equals 4. 3 times 4 plus 2y equals 6. We have to solve for y. 3 times 4 is 12. What do I do next? Subtract 12, right? So we have 2y, positive 6 minus 12. 12 is bigger, so the answer would be negative. 12 minus 6 is 6. Solving for y, we divide by 2. So y is equal to negative 3. So the point 4, negative 3 is our first point. And the second one, we decided to pick, let's say y is equal to 3. Plug that into our equation. 2 times 3 equals 6. Two times 3 is 6. Subtract 6 from both sides. 3x, 6 minus 6 is 0. Divide by 3. So x equals 0. Make our graph. So the first point, 1, 2, 3, 4, and down 3. Our first point is at 4, -3. And the second one is at 0, 3. So don't go anywhere on the X and go up 3. Connect the dots. And there's your graph. That's my plotting points. All you need is, how do we know this is a linear equation? Yes, so does this. How is this is not a linear equation? This one will look something like this. That's in standard form. And that would look even more weird because it's got a bigger number. No, the reason being because a linear equation does not have any special operations. The X or the Y, they don't have a power, they don't have a square root or absolute values or anything. They're just X and Y, nothing else around them. No, actually, that's a very good question. When you make a table, pick any number. Pick any number. Give me any number. For 2. So we put 2 in there. You could for the next point, you could pick another X value or you could pick a Y value. So in other words, the values you pick could be anything. Yeah, because there are infinite number of points here. If we put 2 in there, 3 times 2 is plus 2y. So 3 times 2 is 6, plus 2y equals 6, subtract 6. 2y equals 0, so y equals 0. So the answer would be 2, 0, which is exactly where that is. So yeah, because no matter, as long as it works out, because the thing about it is sometimes when you pick a value, you may get a fraction. So that'll be very, so if I picked a 3 for an X, if I picked 3 for an X, 3 times 3 is 9. So this is X equals 3. Subtract 9 from both sides. 2y equals -3. Divide by 2. Now you have a fraction. Those are hard to graph, so can't use that one. Pick another one. All right, so yeah, any numbers you pick, put it in there. All you need is 2 points. Once you find them, plot them, and there you have it. That's the plotting point method. The next one's easier. It's similar to that, but it's much easier. The next one is the intercept method. Method 2, the intercept method. With this method, you find where the graph crosses both the x-axis and the y-axis. Then connect those 2 points. If it works, this method's the fastest. So here's an example. We use the same equation. 3x plus 2y equals 6. Really quick here. Remember, an intercept is where the graph crosses an axis, right? So what would be that location? No, this is the x-axis. What's that location? 4, 0. How about this one? How about this one? How about this one? Anybody? So now, with these 4 points, what do they all have in common? The y-axis is 0. So to find the x-intercept, step 1, set y equal to 0. Then solve for x. Because your x-intercept will always be an x value and the y is 0. It's always going to be that way. So to find the x-intercept, remember, think about it. If you're looking for the x-intercept, do you need a y value? No, you don't. No, because we're only looking for the x-intercept. We don't care about the y. So we get rid of it and only solve for x. For the y-intercept, what do you think you do there? Yeah, get rid of the x, set x equal to 0. And then solve for y. And in this one, you're always going to have 0, comma y. That's the y-intercept. Put your phones away. If you're in the class, come to class. If you don't want to come to class, play your text phone games outside. So let's find the x-intercept of this equation. Find the x-intercept. What do we do first? So we have 3 times x, 2 times 0 equals 6. 2 times 0 is 0, so it disappears. Divide by 3. So x equals 2. The x-intercept is at 2, comma 0. The y-intercept, set x equal to 0. So 3 times 0 plus 2 times y equals 6. 3 times 0 is 0, so it disappears. We get 2y equals 6 divided by 2. Y is equal to 3. So the y-intercept is x0, y is 3. If it works, it's much faster. So we got the points. So 2 comma 0. That's the x-intercept. 0 comma 3, that's the y-intercept. Connect the dots. There's your graph. This method only works if the intercepts are easy to find. Basically, they're whole numbers. For example, what if that same equation equaled 5 instead of 6? Three x plus 2y equals 5. So let's find the x-intercept. How do you find the x-intercept? Set y equal to 0 and solve for x. 2 times 0. 2 times 0 disappears. We have 3x. Then you divide both sides by 3. So x equals 5 over 3.